So we're going to review SLT6 together using an example problem. So I would like for you to pause and read just the situation up top and highlight the important information. Okay, so the important information that I found, 3 cookies for each of the 96 students, and then I also found that we can fit 36 cookies onto 2 sheets. So letter A asks you if the number of cookies is proportional and to write a table. So I am going to start off by actually drawing out the cookie sheets. So if I have 2 cookie sheets, then I know I can fit 36 total on the 2 cookie sheets. If I were to say, well, if I want more cookies, I could literally double this. And this is actually what a ratio does for us. If I want to make more cookies, I can make another 36 cookies using 2 more cookie sheets. So that in total gives me 72 cookies, and then I end up with 4 cookie sheets. And then the last thing I could do easily is, what if I only wanted to use 1 cookie sheet? If I wanted 1 cookie sheet, then I only can make 18 cookies because that's 36 cookies divided by 2. So what we have here are some values that we can use. We can even say, well, if I want 0 cookies, then I have 0 sheets. I can use what they told us, 36 cookies fits on 2 sheets. We figured out that 72 cookies fits on 4 sheets, and that the 18 cookies fits on just 1 sheet. And it's okay that the numbers are not in order, but the table is correct. So how do we know if the table is showing a proportional relationship? We have to figure out, is there a value multiplied by each of these that will give us this value? So take the number of cookies, multiply it by some number, and it should give us the number of sheets. So I'm going to call those X and Y. I'm also not going to write this multiplication symbol anymore, and I'm just going to put parentheses, and that's so we don't confuse it with X. So if I do that, I could use mental math, but there's also a way to figure it out. If you take the Y value and divide it by the X value every time, that will give you this number that we're looking for. And so obviously don't use 0, 0, but we can start with 2 sheets divided by 36 cookies, and that ends up giving me 1/18 or 1/18. And if I put that value into each of these, so 0 times 1/18, and you can double check these even with a calculator, but every single one of these works, and so that's how we know that this is definitely proportional, because we found this number and it was the same every single time. We also know that that same number is always our unit rate. So I'm going to write our unit rate here. The unit rate, I'm going to write the units with it because it's a unit rate. So I'm going to write 1 sheet divided by 18 cookies. What's the constant of proportionality? It is also 1/18 because the constant proportionality is exactly the same thing as our unit rate. Okay? Lastly, explain the meaning of the constant of proportionality. So anytime you want to know the meaning, you can just use your unit rate with the units. So if you look, our unit rate said 1 sheet divided by 18 cookies. And so we can actually just put in 1 extra word to make this all make sense, and that's the word per. So if I sit here and just put the word per right here, then I have what the constant of proportionality actually means. It says for 1 sheet per 18 cookies. And another way to think of that would be for every. That's another set of words we can use instead of per. 1 sheet for every 18 cookies. Okay? So the next 2 problems I want you to try on your own. I'm going to formalize the mathematics, meaning I am going to show one specific way to do the problems, but I know that for a lot of you, you have ways to do them. So Go ahead and press pause. Try the next problems, B and C. All right, so if I know that I want to make enough cookies for the 7th grade, we have to use this information up here because he needed 3 cookies for each of the 96 students. So 96 times 3. I need 288 cookies. Okay, so that's actually side work. It's not really work for proportions. In this case, if you go back and look at your table, the table gives us exactly everything that we need. So I'm going to take a picture of this table and take it over to the next page. So let's do that. All right. So there's our table. The piece that actually is missing from my table here were the X and Y that were up here. So there was an X and there was a Y. So if you take exactly what's here for each of the values, so if you took every single X value, to figure out if it was proportional, we multiplied every single one of them by 1 divided by 18. And that ended up giving us our Y value every single time. What you have there is actually the equation for the proportional relationship. But you'll notice in class, we always write it with Y equals. So I'm going to write this just by moving my constant of proportionality in front of my X value. Okay? So remember, this here was our constant of proportionality, our unit rate. Once I do that, you'll actually be able to use this information pretty easily. So if I wanted to make 288 cookies, I just have to make sense of, well, my X are my cookies, and I'm going to write my units right on top, and Y are my sheets. So if I take my 288 cookies and I copy everything down, my Y does not change yet. I have 1 divided by 18, or 1/18th, and my X is now 288. So all I'm going to do is take 1/18th and multiply it by 288. And so you'll see here that I end up with 16. So this is 16 sheets. And here's one other way that I started showing some students in class. I said, well, if you know you want 288 cookies, put that into your table. So 288 would go here. And if I know it goes in the column of cookies, then to find my number of sheets, I know because of the proportion that I need to multiply it by 1/18, and that still gives me the 16 sheets. So those are the 2 methods that I'm going to show. You can use a double number line, you can use a sketch, you can use a graph even, but these are the 2 ways I think probably I will be using in class the most. The next question says, if you have 7 sheets, so now how many cookies can you bake? So I'm going to start by using the table again, and the table up here, if we were to just extend it, and I'm going to change colors. So if I extended the table, I would need to put the 7 sheets over here. So if I want to figure out the cookies, I can't multiply by 1/18th, then I would have to divide by 1/18th. I would have to use the inverse operation of multiply because I'm going backwards to figure out this value here. So 7 divided by 1/18th is the same as multiplying by 18 divided by 1. We're using the multiplicative inverse, and that should give us 126, and in this case, I'm looking at cookies. Okay, so that's one way to do it. The other way, which you'll also see me use in class, would be to use our equation. Y is equal to 1/18 multiplied by X. Y are our sheets, and X are our cookies. And so if I use this way, I know that 7 sheets has to go here, And now I have to figure out what this number is. And so to figure out that number, I would use the inverse operation of multiply. And that's how I would figure out that I needed to do 7 divided by 1/18, which still, in the end, still gives us the same number of 126 cookies. Okay? So those are the two methods that you could use. The table method is really nice because you're putting your math inside of the table, and it is helping you visualize how to figure out either the number of sheets or how to figure out the number of cookies.